Hi, this is Tim. Today we're going to talk about how to program a seal-in rung on the Allen Bradley Micro800 PLC using Rockwell Automation's Connected Components Workbench software. This is probably the most popular motor control circuit where you have a start button to start the motor and a stop button to stop the motor. Also, my kids think that we needed to push people subscribing to our channel and following us on social media some more. So please subscribe to the channel, like this video, hit that little bell thing up there and tell them that you want to know all about us. And yeah, follow us on the social media stuff. I'll put it all down in the description. For this video, we're going to be using our Micro800 PLC trainer, and it is still wired per our Getting Started guide. So let's get started. Let's open up a new program in the Connected Components Workbench software, and we'll just call it Start and Stop. And go to Controllers, then Micro800, and we have a 2080 LC20 20 QWB. Version 11, select, Add to Project. And let's go down to that Ethernet configuration and go ahead and configure our IP address for 192.168.110 with a subnet of 255.255.255.0. Now let's right-click Programs, Add Ladder Diagram. Now if I'm going a little too fast for you through this, we have a whole video series where we go through how to download and install Connected Components Workbench, creating your first program, how to download, and I'll put a link to the whole video series in the description. Let's go ahead and open up Program 1. And everything we're going to need is going to be in this Favorites tab, or at least by default it is. So let's bring down a direct contact, examine if closed, and then let's go to our I/O Micro800 tab, and then we're going to be looking at our green button, and that's going to be our start, and that's input 4, so let's make that our start button, and then button 6 we're going to use for our stop. That's our red button. Up here, output 0 is our green light, and we'll just use that to represent our motor load. Now let's go ahead and select that start button. All right, now let's use a direct coil output energize and go back to our I/O Micro800, and this time we're gonna hit the green light. Now this is rung 1 of our bit instruction lesson where you press the green button and the green light came on, and you let off the green button and the green light went off. So what we're gonna do is we're gonna add a branch around this to hold the green light in or seal it in. So let's hit this branch, which is the second instruction here, and drag it down. And then we want to use a reverse contact, examine if open. And we're going to go to our I/O Micro800 tab, and we're going to hit the stop button. Now, some of you are going to jump on me right away and say, hey, Tim, you can't use a normally open contact on the stop button. Well, first, there's nothing illegal that says you can't. Now, whether it's a good idea or a bad idea, we're actually going to go through that in a future video. We're going to talk about different contact configurations and different instruction types and how they affect that stop button, mainly during power failures, during wire breaks, wire shorts, things like that. But for now, the main reason we are doing it this way is because our trainer is still wired by our Getting Started exercise that we did. So it is a normally open stop button. So now let's drag down a direct contact, examine if closed. And go to our I/O tab, and this time we are going to come up here and select our green light. Now if you're new, you may say, well wait, that's an output, you can't use it on input instruction. Like I said in my bit instruction video, this instruction just goes and looks for a 1 or for a checkbox in the case of the Micro800. Wherever this instruction is, it doesn't care if it's an input instruction, an output instruction, a timer instruction, counter instruction, internal, whatever. It just goes and looks for a 1 or that checkbox. All right, let's go ahead and download this and see how it works. Again, I have videos on how to download that I'll put in the description. Okay, let's press and hold the green button, and yes, the green light does come on. Now let's let off of the green button, and the green light stays on. Now let's press the red button, and the green light goes out, and let's let off of it, and the green light stays out. Now I'm actually gonna paste a video that we did for the RS Logix 500 version of this video, because it has a step feature that I use to really break down the PLC scan cycle into single scans. And it really did a good job of explaining this. That feature is not available in the Micro 820, but the principles work exactly the same. But before I start that, let's make sure we do understand, at least on the basics, what's going on here. So no buttons pressed, green light off. This instruction goes and looks for a 1 or a checkbox. Where at input 4? Do I have one? No, so it is false. Then it comes to this branch, and when it comes to an end of the branch, it goes down to the beginning of the next branch, and this instruction says, go look for a 0 or an unchecked box. Where and input 6. Then this instruction says, go look for a 1 or a checkbox. Where at output 0? Do I have one? No. So it's going to be false. It comes back to the branch, and then it looks and says, did I have any continuous paths of true from left to right of any of my branches? And it didn't. So it's going to pass false conditions on, which is going to go to this direct coil. False direct coil goes and writes a 0. Where to output 0. And that's why the green light is off. So now let's press the green button. And here's where my RS500 video does a little better, because I can't stop it to really talk through the single scan easily. So let's press it though. This instruction is going to say, go look for a 1 or a checkbox. Where at input 4? Do I have one? Yes, so it's going to be true. And it's going to pass true conditions on. Now, just because it's true, it doesn't say, well, let me just move on. No, it's still going to go back to the beginning of the next branch. The stop button, this instruction is going to say, go look for a 0. Where at input 6? Do I have one? Yeah, so it's going to be true. Then it goes on to this instruction, which says, go look for a 1. Where at output 0? Now, here's where it's tricky. For that very split moment, that first scan where I press this button, this is actually false because the green light wasn't on yet. So this is going to be false. So let's just imagine it's false. Like I said, I'm going to go through this in a lot more detail in a second. So then it's going to go on to here, and it's going to say, do I have a continuous path so true from left to right? This branch is true from left to right. This one isn't actually true yet. So it's going to go to the green light with true conditions, and it's going to say, go write a 1. Where to output 0. And that is going to turn on our green light. Now the second scan, like a millisecond later afterwards, all of this is still exactly the same, except for now this lower branch is going to be true because that green light is now a 1. Now when we let off of the green button, this instruction says, go look for a 1. Where at input 4? Do I have one? No, so it's going to be false. It gets to the end of the branch, it's going to go down to the next level. This instruction says, go look for a 0. Where at input 6? Do I have one? No, so it is true. It's going to go to this instruction and it says, go look for a 1. Where at the green light? Do I have one? Yes, so this instruction is true. So now this lower branch, or that seal end, is true. It's going to pass true conditions on, go right a 1 to the green light. Now again, this is one end of the video I'm going to show you a lot better, but we press the stop button. That moment we press it, this instruction still, it's going to go look for a 1. Where at input 4? Do I have one? No, so it's going to be false. So this instruction is going to say, go look for a 0. Where at input 6? Do I have one? Yes, so it's going to be false because it was looking for a 0 and it found a 1, so it's false. Now at that split second, this green light is still true. So this one says go look for a 1, where at output 0. That first scan, this is true. Then it gets to the branch and it says, did I have a path of continuous trues from left to right? Well, it didn't on this one because the stop button instruction wasn't true. And it didn't on this one because the stop button instruction wasn't true. So it's going to pass false conditions on to the direct coil, which is going to go right as 0 to output 0. Now that second scan right afterwards is going to make this green light also false. So now we're going to roll some footage from that RS5000 version of this video where we actually step through each single scan through this process. And I think it does a great job of explaining it. And let's walk through the steps that it actually goes through. First, PLC is scanning constantly. I mean, it's probably scanning 200 times a second maybe. And each time it comes around, it goes to the first instruction to the left on the top row. And this one is an XIC instruction, which says, go look for a 1, where an I:0 \/0. Now, if you're not sure how to navigate to it, you can right click right here and you can go to data table. And there it is. It says, do I have a 1? Well, no, I have a 0 right here. Now, so it is going to say it's false. Now remember, and this is where it really becomes important, is that just because an instruction's false doesn't mean it doesn't do anything. It means it is going to have a false coming out of this instruction. But then it gets to this branch right here. It's going to get to the top there. It's going to enter this branch. What this branch means is go back to the beginning and go to the next level. So it's going to come back right here. So it does not go from this start button to this output, because you'll hear a lot of people say, well, yeah, it is off, so the output turned off, but then the next one turned it on, so it's chattering. It is not chattering. It goes from this start button, it sees this branch right here, and it goes back to right here. And this says, go look for a 0. It doesn't care whether it's connected to a normally open, normally closed. It's an XIO instruction that says go look for a 0, where an I:0 \/2. So we'll go to it and it says I have a 0. So this instruction is true and it passes true to the next instruction. This one is saying go look for a 1, where an O:0 \/3. Go to it, you see we have a 0. So this is false. So now it comes back to this branch right here and it says, well, were any of them true? If you remember, the start right here was false, and now this branch right here is false. So this one's false, this one's false. So it's going to go to this OTE with false conditions. And an OTE that is false, remember, it does something. It says go write a 0, where an O:0 \/3. Now remember, every time that it comes around to this program, it goes and writes a 0. It has a 0 there, it still writes another 0 over top of it. And we're actually going to use a feature of RS Logix that I have never found a use for until this video. So one, don't go out thinking you're going to test machines with this feature. But what we're going to do is we're going to go here to where we see remote run, click the down arrow beside of it, and we're going to click test single. And what this is going to do is it's going to make this PLC only run one scan. So I'm going to click go single scan. And then you see over here, now it's saying test single. So now what we can do is we can go through this scan by scan and just kind of slow down for a second what exactly is going on. So what I'm going to do is I'm going to press the start button. Now first, as you see, when I sit here and press this button, nothing's happening in the PLC. And that is because of this test single scan function. So if I hit test single scan, it's going to go through a full scan, which includes reading inputs, updating input data tables, executing code, and updating its outputs. I'm going to press this button, and then I'm going to click Go Single Scan. And you can see that it went through a scan. Now I'm going to let go of this button. Now the PLC doesn't know I have, but mainly my finger will get sore if I don't while I'm talking to you. So we're going to go through exactly what it just did. So first step, which I kind of skipped on the first round through this, is the first thing it did is it went and read its physical inputs. And so button 1 is connected to I:0/0. And it said, I have current. So it goes here and it wrote a 1 to that input. And it went through all the rest of these. In fact, you can see, oh, there you go, switch 1 was also on. And so it wrote a 1 to it. Then it started executing its code. And it had this XIC. It said, go look for a 1 where an I:0 \0. Do I have a 1? Yes. So it is true. Now, just because it's true doesn't mean it moves right over here to the blue light. It's still going to get to this branch, come back up, and it's going to scan this one. Now, I'm going to do a little something here because now it's not quite true, and I want to make sure that we fully understand what happened. Is at the beginning of this scan, this output was a 0. It was not on. So I am going to toggle this bit because this is really what it looked like at that moment of this scan. So it was true here. It came up here and it got to the red button. The red button is an XIO. It said go look for a 0. Where? An I:0 \2. Do I have a 0? Yes. So it is true. It takes as true and it moves to the next instruction to the right, which is an XIO, and it says go look for a 1. Where? An O:0 \3. Now it's so very important, even now, that you realize that it's not going and looking at this OTE. It's also not going and looking at this physical output. It is going to look at the data table, and right there you can always right click them and say go to data table, and that's exactly where it's looking. And it does not have a 1, so it is false. So our lower branch here was true. Our top branch was false. Well, on a branch, if you have a true in any of them, then your result is true. And so it passed a true on to the OTE. Now this OTE executes whether it's true or false. It still executes every time. This time though it's true. So it says go write a 1 where an O:0 \3. Now again, it is writing to this data table address. It is not writing this physical output. So it went and wrote a 1, and at that point then our rung looked like it does now. Then it keeps coming around to the next rung. It sees this end statement, and at that point it goes and updates its outputs, which included turning on the blue light because O:0 \3 was on. Now remember, in the PLC, since we're doing this single step, it still thinks my finger's on it. So I'm going to do another single step with my finger on it, and you see nothing really changed. Now it did the exact same scans we just did. So now I'm going to let off of the button, and we're going to do another single scan. So what happened there? First thing, at the beginning of the scan, it went and it read its inputs, including, mainly we're going to focus on this button right here, our green button, which was connected to I:0 \0. And now it does not have current because I've let go of the switch, so it wrote a 0 to the data table. Then it went and began executing its code. So our first instruction was an XIC, said go look for a 1. Where? An I:0 \0. Do I have a 1? No, I have a 0. So it says false. It gets to its branch here, and it goes back to its next level of its branch, and it sees an XIO instruction. The XIO says go look for a 0. Where? In I:0 \2. Do I have a 0? Yes. So it is true. Now the XIC here says go look for a 1. Now again, it is not looking at this blue light. It is not looking at this OTE over here. It says go look for a 1 in O:0 \3. Do I have a 1? Yes. So it is true. So our top branch was false, but our bottom branch was true. So it's going to pass true on to this OTE. So since the OTE is true going in, it says go write a 1. Where? An O:0 \3. And that is why our blue light has stayed on even after I've let off the button. Now again, remember, we're doing this single step thing, and guys, besides this video, I have never seen a use for the single step function, so don't go out there doing this. normally. So now I'm gonna put my finger on the button. Actually, let's go ahead and hit the single scan button again, just so you can see that, yeah, all right, we scanned, nothing happened. So now I'm gonna put my finger on the stop button and I'm gonna press single scan again. Now I can let off the button because it's finished its scan. But what did it do? First it went and read all its inputs. It said, do I have current on each one of those? Now, it doesn't matter if it's a red button, if it's labeled stop, or what it is. All the physical inputs are going to do is say, do I have current? Since I had the red button pressed in, I had current. And that's why if you go over here to the input data table, I:0 \2 is a 1. So now it goes and it runs, it executes its code again. It says, the XIC says, go look for a 1. Where? And I:0 \0. Do I have a 1? No. So this instruction is false. It gets to the end of its branch and it goes to the next level. And it looks at the red button and it says, go look for a 0. Where? And I:0 \2. Do I have a 0? No. So it is false. Now, even though it's false here, it still continues to the next instruction. And the XIC here is saying, go look for a 1. Now, remember, this light was on at the beginning. So while it's showing off now, when it was going through this part of the instruction, it had a 1 in it. So it says, go look for 1. Where? And O:0 \3. We go to the element. Do we have a 1? Yes. So this is true at this moment in the PLC scan. So again, this one was false. This one was true. So it has to have a continuous line of true statements from left to the right to be true. So our top rung is false because of this one. Our bottom rung is false because of this one. So it continues over to the OTE with false conditions. And a false OTE says, go write a 0. Where? At O:0 \3. Wrote it 0, and that is how it ended up looking like this. Then it goes and updates its outputs based off of that data table. So the PLC then goes to this data table right here. It updates its outputs, which included turning off the blue light. So easy takeaway from this one is obviously now you know how to do a seal in, but the more important takeaway here is really starting to understand those steps the PLC took for that seal in rung to work. Hey, this is Tim.
And this is Amber of TW Controls. We run the automation store. Hey, thanks for finding our channel.
Here's a playlist with some similar videos.
And YouTube thinks you'll like this video.
Please like our video and subscribe to our channel.
And if our videos have helped you make some money and you're not using our products, please consider supporting us on Patreon.
Till next time.
See ya!